Glad to see you all here.
У нас будет это. We are hiring. Не знаю.
Just to make sure you guys are familiar with the schedule. Yep. Perfect. There you go. Да.
Что, нам нужен?
Нет, я уже отмазался от всей работы, так что...
Ну тогда все хорошо. Полгода. Звук нормальный, микрофон будет?
Можешь скинуть линк на Hangout,
Да, сейчас.
который у нас появился? Ну, so guys, how are you doing today? Hey, happy to see you here. Happy that you made it despite the weather. So we'll start shortly. I guess we'll wait for another 5 minutes. sure everyone is here, and then we'll start.
Сейчас я скину там на YouTube на страничку.
Hello guys. Hello guys, welcome to Scandinavia. Nice to see you here. I see some of you. We were working with some of you. Warm welcome. Today we want to share with you our experience with Docker. We were attending some speeches ourselves, and we found out it was almost useless for us because we heard like, guys, we did this, we did that. We invested half a year, and we are cool now. Today we want to tell you about our failures that made our way to success. So today we will speak from three perspectives. I will speak as a DevOps and partial as management about these problems. Alfred is a developer.
Development issues and stuff I faced while developing. And this is,
I will speak as an ops or admin view, describe what the quicks, most punishing quicks when they are developing.
Okay, so let's go. First of all, in containers we trust. Some time ago we decided that we are fine to invest our time, to invest effort into the Docker technology, which is kind of high technology, right? That is why we are here today as well. But we had very small basic knowledge about this. But by that time we made a decision. We thought that we had problems. We had problems with our infrastructure, with our sorry. Yep. We had problems, and we found out Docker would help us to solve these problems. So we started to work on it, to implement it in our daily routine process. The solution, as I said, was Docker. We treated Docker from our existing experience perspective. So we were thinking of it like we used to think about services which are somewhere on the servers, even in the cloud we had such experience. But still we found out we came to more problems implementing Docker. So why Docker? We had an issue when developer teams are responsible for the deliverables. They are fully responsible, not only the code, the feature, the bug fixes, entire delivery. And by that time, we called it "Give me sudo problem." When developers were constantly pinging admins and raising concerns to PMs and management that, oh, we can't achieve that because we don't have access, we can't change configs, we can't influence environment, we can't control it. That is why we thought that we must find a solution to allow admins or ops team to do what they have to do, to care about the infrastructure, to care about security of the infrastructure, but at the same time, give developer full control of the environment. So they are not responsible only for code, for coding stuff, but also for entire environment and all the dependencies, not only code dependencies. That was the first step.
Yeah, so here comes my part. I'm very young and I like new modern technologies. And because I like them, it's complicated for me to use them in production. So our CI tools does not allow us to use them because every time I found something new and I asked on this admins to install something on server, they say no, we won't, because too complicated to go. So I need something to be more independent. I want to try new technologies. And I also work in multiple environments, like 5, and I have to switch very rapidly, and they all have different setups and different versions of languages. So switching is complicated. It takes time. And the solution for this is Docker. So I started using Docker because of this. Yeah. And today I will tell you about issues I faced during my investigation of this amazing Docker. Yeah, Docker platform. That's, yeah. And built on continuous integration, which does not really matter because it's also discussed. Yeah.
As admin, worked with the plate servers. It's like big boxes of everything tossed inside. Developers always trying to switch something, implement something new. Always this flow of requests coming. So the Docker might be a good tool to build application fully with your software code inside, ready to use. The developer environment will be more similar to production, so it works in my local all the time, but not in production. Now the developer will have all tools, all services he needs. By using this workflow tool, we can more reliable way to build a code, test it before running it into production. Also, Docker gives us advanced techniques of deployment, some new ways of zero downtime deployments will become reality. That's the most cool part. But
the quirks of Docker. Again, as I said at the very beginning, we heard that Docker is cool, it is cool, but it requires time, it requires effort. So that's the main part, where we have failed, what we have to learn before we get cool with it. The first thing is human factor. As you know, each language, its technology is made by people for people, right? So whatever you take, you must take care of your colleagues, take care of their skills and knowledge. So they can really feel the support of the core, right? There is a new technology, there is a team who develops it. But you develop it for your colleagues first of all. So you must pay attention to how much comfortable your colleagues are with this technology. We thought that there were a few other attempts from specific teams for specific tasks to implement Docker. We thought that creating a really cool, good template by admins and developers and we together can make a really great thing. Actually, we did it, but turned out it's complex. But we achieved that it's tweakable, so it's configurable, right? But it turned out to be too complex. We also thought it would be cool, Alfred said, to switch different environments in just minutes, different versions, different services. That's cool. But again, the complexity was the pain. The same with replaceable elements. So our template actually is made for Magento 2, as it is our basic not framework, but platform, which we are using right now in Canada. And we took care of big amount of scenarios. So there are basically two versions, open source and paid. So there are different services. We took care of this. And also we took care of application bootstrap itself. So developer don't have to type 10 times the same day, the same amounts, and CLI, etc. So it's actually like local deployment made with Docker, with Docker actually itself. But still, we failed at that moment because developers don't know how to use it, don't do actually. We took a look at our documentation and what we found out. It was written good, it was written deep enough, but it was written by author for author. So it was not dedicated to people, colleagues who were not working at this time. That is why it is important to provided basic scenarios without explanation. We described some scenarios, everything is fine, but people think we don't understand how it works. We can't. For other cases, we provided explanation for complex parts, but again, we got complaint that we can't use it, we don't understand what works behind it. What we found out, how we sorted out, we helped. We just were walking around the office and explaining everything to our colleagues, but what's important, we were encouraging them to ask questions. More questions they asked, it was better for us because we could rewrite and restructure our documentation. And we did it 3 times because the template was unfolding, it was growing, we were getting more and more feedback. And it took us 3 times to rewrite the docs until they become useful. Education was another process in parallel. We were meeting our colleagues with some designated tasks, some planned workshops with small, let's say, tasks to explain them parts one by one. But we found out we had different expectations. Developers thought of it like we print in single command and we get everything done, but it is not available from the very beginning until we get knowledge. We found out there are colleagues who could and committed to our template, not working on it. But there were also colleagues who actually could not, for example, differ build state and runtime state. So they were completely missing the difference between the states. But everybody found basic knowledge to be fun and exciting and promising. It's cool to use it. I will use it. But when they saw a template, they said, "Oh, I got an issue. I got an error. I don't know where can I find my notes." So it turned out we compiled it a very complex solution that must be taken care of actually even before we start. So probably we could start application earlier, or we could include more steps to teach people with basic things so they are not afraid of the big final solution.
Yes, nice. So, as a developer, from what you start, the first thing you do in your Docker file, you define your best image, right? And I try to learn a lot, try to read the information, what is most optimized, what is the best base image. And at the moment, I thought that, well, which Linux go for best?
Alpine.
Yeah. So I choose the Alpine Linux, started setting my container, I chose it, I set up with all the infrastructure inside, and I faced an incompatibility issue. Well, that meant that some modules cannot be installed in Alpine Linux, which is pretty bad. So what should I do? I should repeat. I should choose one more image, go through the infrastructure setup, and maybe face, maybe not face new issues. So my recommendation to you is, first of all, to start with something you know. Don't try to optimize anything before you completed it. So I lost my estimates, I ruined it, but I learned a lesson that if you choose your base image, do it on something you really know, like Ubuntu. Of course, your image will wait a lot, but you will know what you are doing. You will be in your friendly society of, like a friendly operational system. Well, also, for the beginning, I want to speak about something basic, some basic tricks that in the beginning, really, I did not understand. So disappearing folder, how it is. So we go into our Docker file, and we copy some JSON files, some Python JSON files to install our NPM modules. And then we take a look into our build image, and inside the image we see that we have in our user XRC folder, we have package.json, package log, and node modules. So node modules installed, amazing, fine, I'm cool. So then in the runtime, when you sync the volumes, you see that, oh my god, where is my node modules folder? Nobody sees it because it's kind of not there. You see all your source files, cool, but you don't see the folder. So where is my folder? Guys, I want you to invest. Help. Guys, where is my folder? Where it's gone? Who knows, really? Like, I want you to raise the hand, tell me. So, okay, I will tell you. Mounting Docker volume into the container folder makes the folder initially there unavailable. And this is a very common issue. And you face it in your first day of working with Docker. And how you solve it is also pretty simple. You have to copy your build directory into your runtime directory at the moment of when you start the runtime. For example, your script could look like this. You choose your build directory, then you do the installation stuff, then you go back inside of your application directory, which will be available in the runtime, and you copy your build files into your application file. This way, you won't have your application. This way, you won't have your builded files disappearing. So yeah, keep this in mind while you're doing your files. Next one is optimizing by building cache and then disabling it. It looks very strange, but why? Why should you ever do this? So imagine the situation which looks like this. You put all your stuff, you had an amazingly long Docker file, and you put all your stuff inside of a bash file, which you want to execute. And you also need to pass some arguments inside of it, environmental arguments, variables, which actually be different from one build to another build. So your Docker file looks like this. You copy your build bash file, then you run it. And what's wrong here? Let's take a look. So copy, what it does, how it works with caching. If the file is changed, Docker will see this and immediately invalidate the cache for all the following lines of Docker file, which means that we are good. If we change the build stack, it will be copied and then run. Amazing. If we change some lines, so we don't have an issue with file which is. So if we change the file, it will be run anyway. So we are all good. But we want each build file to have this run because some arguments are different from build to build. So what should we do here? What should we do? We should ask us a question, first of all, that maybe it's all good, let's keep it. But it's not good. It's not good because the build, the Docker, will cache all the lines before. Oh, sorry. Yeah, it will cache. This. If nothing is changed, but we need to change the result based on the arguments. We should hack Docker a little bit to say that we don't need a cache actually. So don't do it with cache. So you have to use some random argument and then pass it as a parameter. So Docker won't think it's a cacheable command. Yeah. Am I right? Okay. Nice. So, two amazing options how I use to mount volumes. So, when you do complex Docker files, in some moment you understand that you need to link your containers, right? So, how you do this? Of course, with Docker. Yeah, sorry, I forgot the name. So we can do this with Docker Compose. Amazing. I'm sorry, telling about Docker, forgetting the basic stuff, but sorry. So, how you pass the volume? The first very basic stuff, which is in all examples, you do simple volumes. You specify your volume and you map it to the containers directory. What's wrong with here? Actually, it's maybe all right, but it's hard to reuse this volume because if the container falls, if it breaks, so if container falls here, you actually lose the volume and all the files inside of it. You have to backup it somehow. So then we come to the next possibility. You can use your kind of dummy containers, which are volume-only containers by Tianon. It's great guy. And then you can specify volumes from. The issue here is that, okay, if this container falls, this one will stay, so good, we can keep the volume, we start our containers, we'll be fine. But volumes from is being deprecated from newest versions. So we have to find another solution, which is actually currently a best solution. So it looks like this. The name of volumes, so you specify the volume before, and then you map this volume to your container. And it's amazing. It's a new way which solves a lot of issues. Maybe you know.
Well, one of the issues in the containers that the container itself is ephemeral, and the data inside is not persistent. With these named volumes, we have another subset of Docker volumes, so you can change them, move them independently from containers. Also, if containers dies or you need a new revision of code, anything, volume will stay. So your data will stay.
No, it's your part.
So, in that perspective, it's all cool. Data is inside, persistent, it's okay. But where is the cache? There is something still not right. The performance. Initially, Docker wasn't designed for local development. And the first big part of it, that in order to run Docker on macOS or Windows, you need to use a virtual machine. It's a drawback, but it works. Recently, Docker released like a tiny layer, HackerKit, virtual machine, which kind of speeds up everything, except disk operations. I don't know how Apple does it, but it has a really low performance in the matter of disk I/O. Performance, it just runs badly. We have tested on Linux. You have a project bootstrap in 5 minutes. On macOS, you have like 20 minutes. It's all because of file system events that is emitted and the operating system signals that files are updated for the container. Another failure we faced is Linux way of using permissions. Inside container, you would always open all files. When the container maps to your system, all files produced by the container also become root. In a matter of seconds, you have totally non-workable project. So you have control all the time, etc., etc. Another thing we faced not so long for the build and runtime. We prepare some basic stuff in build stage, like PHP, Node, everything. And in runtime, we set up our modules, application configuration, and so on. But we don't know what to choose. And when the deployment comes to dev stage, it takes hours. Another thing, bad use of base image. We have some kind of development environment which are really flexible. You can rerun it all the time, rebuild your new currently usable versions. But in terms of performance, you always rebuild the containers. You always rebuild. You wait like 30 minutes every time you have an application update. It's too long. So, one of the solutions, and it's currently not the solution, but one of the current issues to the operating system, is to force containers to update the file structure all the time. It gives a real strain, it's a cool strain to the macOS, where they really burn all the time. As I said, the storage elements are terrible, so the community solution for this was Docker Sync. It's okay for a small project like Laravel or something, not 10K files, but in our situation, in our Gentoo, the big project also constant updates of the files, install the simple files. So you end up that you update your files, but they are not updated in the container, inside the container. Also, not recent, like half year before, Docker community provided a new driver, OS6FS, which kind of fixes all this. So you have not so bad performance as it was in default, but not so good as it was the community solution. As you can see, there is a cached. There is a free ways how to manage the files. Either in this template, you give the performance of the files to the host system, either to container, or you strictly use the matching system between two. So the container and the host is ensured that all files are in the same place, same version, same content. The Linux way of fixing permission issues is also, you cannot just install Linux and think it's will work. No, you always do the tuning, fixing. So to fix permission issues, we must use entry point. It's executed every time then you pass a command to the container. And okay, but looks like that sometimes. Also, when you build a container, you create a user inside it. So, kind of okay to drop from root to your current user to use it as inside the container and outside. Also, there is a sudo inside the containers, but it was specifically written for containers. It's called Gosu or suexec, C version. So if you need to update your container, do something like stop packages or something, do the plain exec. If you need execution as a user, when you generate the files, exec as a user, minus u, all the time. It's only solution for now. It's the best solution.
Yeah, basically.
That was the part one. So we have like 10, 15 minutes to brief and continue with part two. Yes. Thank you.
Нет.
Okay, guys, so we are about to continue the second part, more technical part. So I hope you are rested and we are good to go. Okay. Okay. Part of the shape, part of the group. The Docker linkage and race condition. That issue came, in some cases it came up, in some cases it not. At first, we had such template. All services, all things linked to our application. And okay, but Docker things that starting the container, it by default means that the container is ready to operate, provide services. Docker itself does not care what configuration or something like Bootstrap or something happening inside the container. So it's not really ready. The first thing was like a microservices approach. If service or dependencies fail, just restart it all the time. But problem is that sometimes all this stack can be rebooted loops again and again and again, draining your instance resources and so on. So we switched to this. We made a strict way of dependencies for application. So application really is needed database and application, not the web server or so on. Also, we had the issue with Varnish. It's a full patch cache. So when Varnish starts, it sees the error on Nginx or web server, and he caches all these errors. And we spent like 2 hours debugging it. Sometimes it worked, sometimes not. It was dependent on how Nginx fast enough started. So we implemented proper way of linkage. Application is dependent on MySQL and Redis. Nginx dependent on application. So when application is started, only after that the Nginx started. Nginx ready with porting the Varnish. Also,
there is a wait for it is high. This is a Docker provided script. The only use of this script is to ping the port and wait for response. I'm ready to accept connections. By default, it's generally a good idea to determine that database is up, Redis is up, or something. Also, different projects have different services, different starting times. Sorry. Also, these links provide DNS resolution inside your stack. So in each configuration, you can refer to a particular service with a name, MySQL or DB. This is the right part is aliases. So you can easily switch. Right, I don't need MySQL. I can switch it to Postgres, but leave the alias behind the same. But in terms of configuration, I don't need to change the endpoint. Also, this is a really good DNS resolver inside. But if you have tests are always waiting on some real DNS name, fully qualified domain name. You can also alias it. So you can easily run your tests in such stack on your local before it really reaches the dev stage and so on. The workflow.
So actually, we were using Docker a while before we started to work on the template, on implementing Docker for company-wide development and processes. And actually, after we started it, we found out that everything we did before was not really good, let's say, this way. Because Docker previously was used as an ad hoc solution, as an extreme and fast solution, for example, for building the production, right? So we faced that the fresh version of application required a real build, so a compilation of assets, pre-caching some internal resources. And we found out it got specific requirements. So our CI tool was not ready for this. We were missing binaries, we were missing even specific service version controls on it. But it was full of legacy dependencies, which we were using in the old outdated versions, and we could not switch it for the different projects, and we got more than 200 projects in our CI added right now. So Docker was used for such things, and of course it was built as a side part of our infrastructure, of our process, and it was built with the tools or with the approach we were using for our services, for our infrastructure, for our deliverables. And we found out it was actually the wrong way to use the Docker. First of all, we thought the Docker is for environment, only for environment. We found out it's not. We can build an entire application. And for runtime, with only some migrations, which requires real database. Everything else can be built and stored as an image that is always ready to run. Docker is meant for decoupling. That's absolutely right. It's meant, but what exactly are you going to decouple? Because Docker provides decoupling from between environment and the infrastructure. It doesn't decouple environment from code, from application. It's vice versa. They are coupled together. So it is now possible to give full control of the runtime to developers without overusing help or overloading the upstream with additional tasks requests. But at the same time, we found out it's not enough to just give it control. It's for building, integrating, and control is just a tool. Actually, Docker is just a tool that gives developer a control. Because when developers are missing skills, they can't fully take in control of them. And it's not only the things that are related to application, how to configure application, how to store the configuration, but it is also about configuring entire services that are needed to be run. And that knowledge was missing, and this knowledge was a real problem for us. How to encourage developers to try, how to allow them to feel that yes, it's cool when I can configure application as I want. And additional thing I would like to touch is coupling, decoupling, is some points of 12-factor application methodology, which describes how application should be constructed, right? How architecture should be arranged, etc. So just a few points from that quite a big and useful document. I hope you're familiar with. Its dependencies. So with Docker, we found out we can handle not only the code dependency, not only the libraries we need for our code to work, right? So we want to reuse it, but we can also fully prepare all dependencies for environment. PHP, Node, and everything else you might need. So that was a useful thing, and it should not be decoupled anymore. So environment dependencies, like proper versioning of services, is also a dependency for application when you're running the Docker. Config. Config is meant there. Config should be stored in the environment, in the environment. That's true, and recently, again, our default application we are working with Magento provided such a solution from the application side, how to store config somewhere else, not in the database or in the code, but it is meant like, oh guys, you should not keep your config under the version control system. So how should we handle it? There are no clues. So we found out Docker helped us to create a process that allows to implement some sort of standard or flow, understandable for developers, how these configs are treated, where they must be kept, and how they are reused or imported to the application. And finally, build, release, and run. These three steps must be strictly divided and not be compressed together. And again, with Docker, we faced that our colleagues, it was hard for them to understand the differences between the build, the release is not so good for, is not really good description of what happens in Docker. But build and run definite layers. So it was a great example that came into the everyday's duty for our colleagues. What is built, what is run. So these are separate states, and it helps us now to explain what's happening. Because teams who are working with Docker right now, they don't have problem anymore to understand what does it mean in CI tool when I run build, then I create a release, and then deployment is running. So where do I check my deployment logs? What is wrong? Where should I look at when deployment is failed? So it is now easier to speak with them, to help them, to explain them, and to teach them to solve their problems on their own.
Yes. One of the topics that struggled for a long time. When you use Docker, you build your application from Dockerfile. So you really don't need some kind of complex system to run the script. You can just toss the bash script inside, all runs. But Docker uses storage a lot. If you have really big application, every time you build it, you create new layers and new storage. To be precise, our base image now kind of 2 gigabytes every time. It builds 2 gigs all the time, and for each project. So if you are looking at Docker as a continuous integration system, look at storage, implement the ways to clean up your local CI server, endpoint servers, everything. At some point, after a month of use, 1 day of usage, we deployed our template, and then in the first day, we drained all the I/O of the CI disks, all the space of our CI. So, I don't know, maybe in 3 hours, it was all depleted. So we really underestimated how Docker uses the storage. Yes, those caches. Every time you build and you do, if you flush the caches or you build without caches, it generates a new layer all the time. Kinda okay, but enough. Also, when you build, actually using your Docker to prepare everything before deployment, you use a lot of system, CPU, a lot of memory, a lot of everything. So if you're moving to Docker, plan your CI to be scalable. It's really needed. That's the one of course. And another interesting question. Cross-mouse. You have application. You have multiple servers, multiple binaries of some sort, looking in the same folder. This is part of our template. So you have application and web server pointed to single folder. But there is one catch. If the volume is empty, the first container which runs copies the internal image contents to the volume. But next time when you run the container and the volume already flooded with data, you will always get the volumes, all data. I've seen like 3 tickets where it's discussed, should Docker overwrite the data or not? And it's really hot topic there. So for now, we have a solution to give at data volume every time we deploy. It costs a lot of disks, disk I/O, disk storage, but it works. Yes. Also, race conditions. I already mentioned the race conditions when services start, but also this affects the mounting. The first container comes up, and with such mounting point, the first serve. So, also link your containers properly. Think about it. In some sort, in dev and staging, it's okay to write the volume. In some environments, also in production, it's not okay to write the whole volume, but always copy inside. So the only way for now in production deployments, you always copy files. You cannot just toss them inside and go there and place. Currently, we're using simple machines with Docker clusters. There is no clusters, something like that. And the most punishing part, when you use Docker on plain machine, you have access only, you can restrict or not restrict the access to the Docker socket. So you can reuse the commands. So you cannot restrict people to use only specific containers of the host. If you give all or nothing. Also, those binding ports, always, you cannot rely on random ports or random bindings that Docker provide, because you have to track them. Our template, our configuration grew enormously because of those hosts made for specific environment. Also, containers is thermal, but we have, you need an additional service for SSL termination, traffic routing, etc., etc. And it can be a separate container, or it can live in host, but it must be separated. You cannot rely on whole stack in single deployment. Also, Docker containers, we try to implement the legacy tools we use inside them, but we fail. Also, it counts towards FTP, some authorization services, and so on. So, think of Docker as a binary sum, but they don't have IP specific, don't have port specific. You can set them. It will not work. In our case, it was simple to use. Those hosts don't really need to be maintained all the time. We don't have rosters or something. Just you start it, up install Docker.io, or everything works. Also, we're using the same template created for local, the assembler for development, staging, and so on. And we are using a lot of environment variables. They're working, not always working as intended. But eventually we came up that all the applications are provisioned from those environments. So we don't store them. The workflow I mentioned also works at full power, full. That's how we currently use, but the drawbacks are function. So, I have a question. Do you want more? Or just we skip it and go for questions? Raise your hands if you want more. Okay. More brainwashing. Okay. The solution we are coming with the Kubernetes. It's hosted on Amazon. It's okay. Amazon states that they handle like 60 or 70%, well, 70%, yes, of the Kubernetes deployments. So it's a great platform to use it. Also, they provide the tool written by the Kubernetes community to integrate with Amazon. And why we selected it? There is a rancher has a lot of things to work on. Also, Docker Enterprise provides, but the features I really liked are very close. You can attach a role to developer to stack of containers to distinguish the access. The thing that Docker itself slacks a lot. And it can be really flexible, but it's some kind of overwhelming, but it's okay. When you deep dive in this thing, you will have dream, then developers don't need to sudo, don't blame you that they do not have access or so on. And at the same time, you will have the full access, the full control of the cluster. This way of deployment is fully scalable, vertical, horizontal. Also, the whole internal services also scalable. We have estimated that we will reduce our costs like 30–40% from existing plans because of this auto-scaling. So if you have, during the day, you have lots of development, lots of people working with containers. You raise more instances. The cluster provisions them, and they are used as a cost for containers. Here come. At the end of the day, activity lowers, the cluster scales down. So really good, really awesome feature. Also, the Kubernetes itself, like a Docker, it's an API platform. It's very extensible. There is plenty of features that you probably imagined, but they're there. Just a bit of exploring all these things. And maybe we will find some. Also, there is a overwhelming list of features. Not so long ago, like 2 years ago, lots of additional projects raised, also like templating, templating services or something like that, raised and died at the same time because it was overwhelmed. I found one. It's really hard to compare. I found a list of 30 different templating engines for a Kubernetes. Only one is currently working fine. That is Helm. For now, it's everything I have about Kubernetes, and I will provide some information more later. So it's questions time. Feel free to ask. And
would you give some your separate image which you are used for your development? You just,
yes. We are preparing. I like to be. I built a base image fully prepared for our development. Also, it's verified that the code inside is from upstream. Not only it's from PHP, it's verified by its signature. So it's a security measure, really. Yes? More questions? Yes?
where do you store your images?
We have a self-hosted image storage. Currently, it's using web. Docker itself provides directory, some kind of registry. Yes. Now we have a version 2, which most of web AIs support, but only one system extends it's enough to use in production. It's Nexus. So if you want a proper LDAP binding or security measures inside your registry, Nexus is the thing. Yes? More questions? Yes.
It's not about that you have like development so the picture here is about what is your current process. Do you like skin virtual machine that there's a developer is
currently we are using our legacy platform, so it's like virtual machine, bootstrap with chef. So the developers will have access to the machine, and we added Docker inside. So they just log in there and do the same commands, same deploys as they do on Docker.
and like you want to replace virtual machine.
It's not scalable. It's not
Because
scalable.
maybe from different perspective, because actually we have a bunch of virtual machines. Actually, these are EC2 instances on AWS, right? And we got some services which are like internal production grade instances, and we would like them to be scalable as well, and not scalable like we're doubling or quadrupling, right? The resources. Just we want more flexible scalability. And we would like to have possibility to restrict the same, to apply the same restrictions. But we would like to move entirely right to use services. But we are depending on existing services, which are now just separated and restricted for most colleagues who don't need access.
Anyway, yes.
What kind of version of the old images you have? Because if you have a lot of images, what's the point of keep it, for example, for 1 year to 5 months?
Docker itself has a little flaw. If you build image every time for a single, for example, for development, you have always attack development. So every image that comes next also tied to image previously. So in every CI system there is some kind of chop off all the old builds. In Docker, this feature will be implemented only in 2 or 3 months. So currently there is no official way to reduce the space used by Docker registry. Anyway, yes, sir.
What do you use for networking between containers and several hosts? So let's say you
Yes.
have host 1 and the database and host 2, then all the applications goes to host 2 via like internal means or
Currently, we are using a single host deployments, but in terms of scaling, scaling, we are using a canal. That's a Flannel plus Alico. Yes.
During your presentation, you mentioned a lot more disadvantages rather than the question would be
We succeeded.
exactly how do these 2 components operate?
Well, there must be a screen, but we reduce our bootstrap form. So developer teams, someone new, additional member comes in, and he needs to set up their whole project. So we reduce this time from 5 hours to 15 minutes. So it's like time saver in most cases. Also, it's a more convenient way to flow the updated code among the infrastructure. Deployment is always the same. Yes, also and one single point. Developers have full access to the code base and the surrounding environment, so they can install anything they want. We verify that, but in terms of flexibility of usage, it's more convenient.
A part of it, as I have mentioned, it is also a good tool to like somehow enforce some change right from the developer side. And when you give them the environment, so they must take care of it. It's a really great tool to do this. Otherwise, they can just set up it on their local, right? And they say, I don't care. I have my own version. It's working. I won't upgrade. I have PHP, for example. I don't see a reason for it. If you don't care, it will raise conflicts with production, for example, environment. But for now, it is like, hey guys, you got the template. We will help you. Here are the docs. But please take care of it. You're not responsible for it. That's from a management perspective. And that was actually also important for us.
Also, remember one thing. We're preparing the base image. So in terms of security and updates, we can release one base image and everyone will be updated. So it's much cheaper in terms of time investment to update the whole infrastructure among all developers, among all systems, among all environments. Because we're using the same image all the time. Yes.
You mentioned that getting sizes up to use, right? It's actually inside of that.
All developers.
So big.
Currently, we are bundling everything inside, which tools like GCC can be inside. All compilers, all modules, all node modules, which cost a lot of space. It's needed for development. It's not needed for production. It's stripped out. But for development, you need all the tools around you. So yes, it takes a lot of space, but it gives you a convenient way to use it. Also, it's much less than Virgin boxes. Yes? One question. Yes.
As I understand, that's, you have different kind of images for production and for development.
Yes.
How you are separate the development from, how you separate that's all code that's inside the development is ready to go to production. You have some kind of testing system.
He wrote most of tests.
Yeah, how you test all these images, for example, some developers made some changes for how you ensure that it's secure.
I think I got the question. So actually, we are moving forward, actively forward production, production images, right? But in general, the idea is developers are not doing this on their own. So they can play around with actually development as much as they want, right? But they are not really doing on their own the production stuff. So there is always somebody from the ops team or somebody more experienced is helping or at least reviewing in terms of images. Is that the answer?
No, maybe yes.
In terms of security, I will add from admin space. We're using a project named Layer. It scans the image you prepared and provides a list of bugs.
Potential vulnerabilities.
Yes. So if you plant inside some very old stuff, it will scream like it's high, do not use it, and so far very good. There was a question, yes. Docker itself dies. Or Docker cluster. Well, at first we're running. Well, here comes the most hard part to build the cluster, because initially we are using free master clusters, and we're using lots of backups to preserve the data of the master. So that's the thing, the truly valuable. The nodes I can recreate it all the time. So in AWS you have auto-scaling. So if the instance dies, new ones comes up. Also, the tool which we use for rolling releases of the cluster is really rolling. So it verifies if we have changed some configuration and it's wrong, it will fail on first node. The rest of cluster will be intact. You can Google it. It's chaos for reference. Really good stuff, and written by the core developers of the Kubernetes. So it's kind of stable for now. Sufficient or? Okay, okay. Any questions? Load balancing with health checks. Also readiness checks, yes. When container starts up, there is a 2-minute grace time to build it up, like flush the cache or prepare the caches, and prepare the configuration. Yes. Not particular. In AWS, you have Aurora cluster. It's separated from containers. It's up to you how to build. You can use database inside your cluster, so you have all the things inside the cluster. But in AWS, you can use external services, which are really reliable, and use cluster only for code, to deploy the code. But the database itself is really good. More questions? Yes? Settle. Currently, we are using Bamboo, Atlassian Bamboo, and there is a simple script which prepares it. At one point, it builds the image, pushes it to the registry. The second part of deployment, he SSH inside the host machine, pulls the image, and starts it. Also applies all the configuration and variables.
Actually, we're transferring just configs for Docker Compose, and on the server we're having accounts that just run this configs. So the new image is pulled, run.
Look it up. So, more questions? Yes?
We were waiting for this. Thank you.
Yes. Legacy. We have tons of legacy deployments tied to Bamboo for now. So our option is kind of forced for now. But Docker will help us to move forward. More questions? No. Private session. Yes.
Actually, regarding the CI, we have Bamboo because its legacy was an old decision, and we can't just migrate over 100 projects somewhere else. But when we started, we actually tried a few further options, and what we liked was, of course,
Yes, it's scalable, really good solution. In terms of Docker, it runs every task inside the Docker container. So you have fully, forgot the word, fully separated the tasks. All they do not interfere each one. Also, you can reuse the scalable way of CI among the cluster. So you have scalable cluster, scalable CI. Everything scalable, everything good. But you need to something. Let me see. Yes.
Yeah, so the question is about succeeding stuff. How do you measure your success in this work? Do you have some different point to reach this Docker?
The first point was to provide developers a reliable way to test their applications. So this expression won't be tossed at admins that I will provide the developers the same way the application works on production in local environment. That thing the Docker solves us for us. That was the main point of implementing it. One of our good features, but it was the first one. So generally, we can using Docker to create the whole production system, same separate networks, separate containers, etc., to test all these things before going full-fledged environments.
the other success is we start limiting the developers from making mistakes, where they, of course, make mistakes with development, right? Not production. But we start limiting them from making these mistakes and learning them these mistakes. So, of course, we failed at the point when there was not enough knowledge, right? So all estimates were just out of date immediately. But at the same time, we are like forcing, but not forcing, proposing to make a bit more than just write a code and like I pushed, I don't care what happens next. That is kind of our main success and goal from the company side, right? And another thing is Alfred is great because it's a great example here. He was working on completely different stack, and our CI was completely out of date with that stack. He just said. Took 1 or 2 days, and he made his own environment for builds and deployments. And we are not getting this problem like, oh, what shall I do? We have a latest version. I need a newer version. How do I achieve it? The same with our internal servers. A while ago, we have created chef-based templates. It was cool. Why? Almost all projects were based on the same framework, on the same platform. It was Magento 1. Then Magento 2 came in, then different versions came in with different requirements. Then more development came in, like ICO stuff, and it was completely different stacks. And now we don't need to rebuild. It's actually impossible for us to rebuild this entire EMS, we call it, internet management system. We don't need it. We just apply Docker templates and we give Docker to developers. Guys, build whatever you need. That is our success.
How do you apply, for example, some new features or new tools which is used by 1 or 2 developers inside your then how you decide that okay, this is good project, let's use it now and play the next one?
In terms of migrating those templates, we provide a basic template which holds all the resources. But developers, in using their projects, they're copying it and reusing it for their own project. Also, they're altering this template a bit for their needs. So, in terms of flexibility, we have the same stack, but sometimes with different configs, versions, and so on. When a new release comes out, we're releasing the way changelogs were changed, and please just merge the upstream to your project. Also, this template is decoupled from code, so it's no interference in internal. More questions?
What's your next one?
Finish the cluster.
Yeah, finish the cluster, move to it, and move our core services as well. Make it fully scalable and reusable.
Actually, the very next thing is we were doing lately, just before we started the meetup, was a client who asked to run everything in their own cluster, but that was not Kubernetes, it was OpenShift. So it was again another perspective of view to the same solution to the same problem. For example, you don't need CI for that. It's building everything, it's building and it is creating build container and later it is creating a separate deploy container which actually spins up your runtime container. So that was actually a thing that made us reconsider a few things, but we are still up for Kubernetes and we want to push it forward to at least internal production. So then later we can propose it.
More questions? Yes.
Yes, question. How do you manage?
What exactly?
Exactly. I don't know. This one we have a lot of database
External services like database.
External services like I mean like backups, running let's say.
Cool. For now, we have two things to back up. The one thing is database, but it's development database is not really matters because it always can be pulled again from the client and reused. So the one thing we really care about is masters on Kubernetes masters. Their storage must be backup. And etcd provides two ways how to backup. Just choose what you want. Or your snapshot or your offloading. It's up to you. The code is in Git or is in images, so we do not need to backup. It not really makes sense. The Docker registry storage might be need a backup, but it's held by S3, simple storage. So it's a really reliable way. Yes, there is a way to replicate the data between multiple registries. But for now, we are kind of okay.
Actually, a bunch of our base images
built, yes, from scratch. Yes. For now, it's all rebuildable. It's all of manuals. We are really not so scared about wasting some 1.7.
It's actually good to backup your data with someone else, right?
Yes. Staging can be run and built on RDS, but local development dev databases, they in most cases are empty, so no needed really. Yes. Something. That's it then.
Private discussion for one thing. We'll have a small supper for all of you.
Also, if you have some questions, I will be here.
Thank you for the attention. Thank you for coming. We hope it's
It's made by it's